Okay, in this video we're going to be talking about the amplitude, midline, and period of periodic functions, specifically the sine, cosine, and tangent functions. So the amplitude is just the height of a sine or cosine function. And when I say the height of a sine or cosine function, I'm talking specifically about the height from the midline. All right? So it's basically just saying, how tall is a sine or cosine function from the midline. If you have a graph that's in the form of y equals a times sine of x, or y equals a times cosine of x, well, then that graph is going to have an amplitude of the absolute value of a. In other words, this is the form of your function. That a, the number there in front of the sine of the cosine that's multiplied in front, that tells you what the amplitude of your function is. It tells you how tall it is. The amplitude of a standard sine or cosine function, the standard sine or cosine graph, is just 1, because that looks like y equals, for example, sine of x. And if there's no number out here in front, then there's assumed to be there's kind of an implied 1 there, 1 times sine of x. Now, there is a formula that you can use to find the amplitude of a function, although typically this formula is only used when you have a graph to look at. We're going to see this in just a minute. So the amplitude of a sine or cosine graph can be found using this formula. The maximum value of your graph minus the minimum value of the graph divided by 2, and then take the absolute value of it, because the amplitude is always a positive number. All right, so let's take a look at these example problems here. So for problem number 1, it says, what is the amplitude of each of the following functions? Well, when I just have when I have an algebraic expression of the function, finding the amplitude is really easy. It's always just this number here in the front, or rather the absolute value of this number in the front. So the amplitude here, my amplitude for number 1 is 6. The amplitude for number 2 is going to be 4. Notice it's not negative 4, because I take the absolute value of this number here in front. And the amplitude of number 3 is just 1/3. Now, if I have a situation like I do here for this fourth example, in which I don't actually have an algebraic expression of the function, I just have a graph, well, I can still figure out what the amplitude is. And usually it's easiest to do that if I can identify where the midline is. And the midline, I can see in this case, this looks like a sine graph, but it looks like it's been shifted down by 1 unit. And in fact, that's exactly what has happened. So I've got basically a new midline that's right here. And so now I can actually use my formula for the amplitude, that is the maximum value minus the minimum value divided by 2. Well, my maximum value I can see is going to be, let's see, it looks like it's at 2. My minimum value is 1, 2, let's see, 1, 2, 3, negative 4. My minimum value is negative 4. So I can calculate my amplitude using my formula. So my maximum value, 2, minus my minimum value, negative 4, divided by 2. And then I'm going to take the absolute value of that whole thing. So 2 minus negative 4, that's 2 plus 4, which is 6. 6 divided by 2 is 3, and the absolute value of that is 3. So I can see my amplitude of this one is 3. And I could also find that just from looking at the graph. If I start from my midline, well, how tall is it? What's the height of my function from the midline? And I can see that from here up to here is 1, 2, 3 units. So my amplitude is 3. Okay, the midline. The midline is just a horizontal line that cuts the graph in half. And we saw that before on this previous picture, this line right here, it kind of cuts the graph in half. It's not quite the same as a line of reflection because it doesn't technically create mirror images, but it does go right through the middle of the graph there. So that horizontal line that cuts the graph in half, that's called the midline. The midline is always halfway between the maximum and the minimum. And again, there's a formula for the midline as well. We typically say the midline is equal to the maximum value of the function plus the minimum value of the function divided by 2. And again, as we're going to see, typically this formula is used if we have a graph to look at, but we don't have an algebraic expression of the function. So when there is no vertical translation, the midline is always going to be y equals 0. If there is a vertical translation, well then the midline, as we're going to see, is usually easy to determine if I have an algebraic expression. So let's take a look at those same 3 functions that we had earlier. And let's talk about what the midline is going to be for each of these 3 functions. So for this one, 6 times sine x, I notice I don't have a vertical translation. If I did, I would have a plus or a minus number out here to the side of the function. So since there's no vertical translation, then the midline is just going to be just the horizontal line y equals 0. Same for this one, because again, I don't have a plus value or a minus value out here, so my midline for this one is also y equals 0. This one, I notice, I do have a vertical translation. I'm translating my graph up 5 units, and if I'm translating my graph up 5 units, the midline also is translated up 5 units, which means my midline is just y equals 5. Now on this one, we already talked a little bit earlier about where the midline is, and I can see it's this line here that I can draw through, that I can use to cut the graph in half, and the equation of this line right here is y equals -1. So that is the equation for the midline for the one with the graph number 4. All right, now let's talk about the period. Let's talk about the period of a periodic function. So a period is how long it takes to complete one cycle. Or more specifically, at least for the types of functions that we're going to be looking at, we could say it's how many degrees it takes to complete one cycle. All right, so for example, the sine function, if I just graph just a standard parent function, it looks something like this. And one cycle I can see is from here to here. It takes one cycle. Well, the number of degrees that is from here to right here, that's 360 degrees. All right. So from here to here, 360 degrees. So the period of the parent function for the sine function is just 360 degrees. Turns out that's also the period for the cosine function. It's also 360 degrees. The cosine function looks very much like the sine function, just kind of moved over a little bit. And the period of the tangent function, now remember the tangent function looks kind of like this. It has these asymptotes. And the number of degrees it takes to complete one cycle on my tangent function is 180 degrees. Well, once I know these numbers here, once I know the period for each of my parent functions, I can also figure out the period of functions that have been transformed, that is, functions in which I have, for example, sine of 2x. The period of the function sine of 2x, it turns out, is going to be 1/2 of the period of 360 degrees, which is 180 degrees. And I got this number by taking 360 degrees, the period of my parent function, and dividing it by this number right here, the coefficient of x. The sine of 3x, again, I take 360 degrees, the period of my parent function, and I divide it by the coefficient of x. So 360 divided by 3 is 120. 360 divided by 4 is 90. And that tells me the period of any function, any sine function, based on the period of the parent function. So the formula, this period formula for, and this works for sine or cosine, the period of a sine or cosine function, we just say is 360 degrees divided by, and I'm just going to call this coefficient number here, I'm going to call that b, just to have something to call it. And the b, this is just the coefficient of x. And this number here, the 360 degrees, that's the period of, I'm going to say the period of the parent function. Now it turns out that it works the same way with if I want to find the period of a tangent function, except the period of my parent function for tangent is not 360 degrees, it's 180 degrees. So this formula, the formula for the period of a tangent function, is going to be not 360 divided by b, but 180 degrees divided by b. And these numbers represent the same thing. The b value represents the coefficient of x, and the 180 degrees represents the period of the parent function.